In these couple of questions, we will find acute angles in the given triangles by using only tangent ratio. For this triangle ABC, let us name this triangle as A, B, and C. We need to find out all the acute angles. Let's first say that this angle is indicated and this angle is named as theta. We will first identify hypotenuse, opposite, and the adjacent. This angle being 90 degree, if this angle is 90 degree, then the angle opposite to 90 degree angle is always hypotenuse, which is the longest side of the triangle. So this is hypotenuse, and if angle under consideration is theta at B, then the side of triangle exactly opposite to this angle, which is 3.5, is opposite. And obviously the third side is adjacent. So if this is adjacent, we cannot use tangent until we find the value of side BC, the length BC. By using Pythagoras theorem, AB square, which is hypotenuse, AB square is equal to AC square plus BC square. Because we need to find BC, so we will take BC on one side. This will give us equal to AB square minus AC square. Because AC and AB are both given, we can substitute the values for AB and AC, which is 5.9 square minus 3.5 square, and here it is base BC square, and BC square is equal to 5.9 square is 34.81. 34.81 minus 12.25, and the value of this on simplification would be equal to BC square. This is 22.56, but if we take the square root on both sides, that will give us the value for BC, and this value is going to be 4.74. So this is value of the length of side BC, 4.74. Now we have adjacent, we can use tangent ratio. So for triangle ABC, tan theta is equal to opposite over adjacent. This is equal to 3.5 divided by 4.74. This is equal to tan theta. So tan theta is, if this is equal to this, then theta would be equal to tan inverse 3.5 over 4.74, and upon using calculator you can get the value for theta which is equal to 36.44. 36.44 degrees. Now this angle at A, this being complementary angle of theta, is equal to 90 minus 36.44. Angle B, this is angle A. This is angle A is equal to 90 degree minus 36.44, and this is equal to 53.56. 53.56 degrees. So this way we can find out all the acute angles. 53.56, and you can see that in any triangle there are 3 sides and 3 angles. Finding all of the elements mean 3 angles and 3 sides is like saying that we solved the given right angle triangle. And now let's take a look on the second triangle, which is given here, and let's name this as A, B and C. And here we are again required to find out all the acute angles. Let us take this angle at A. If we find this angle theta from triangle ABC, tan theta is equal to BC, which is opposite over adjacent AC. This is equal to 15 over 12. 15 over 12. This is equal to tan theta, and theta would be equal to tan inverse 15 over 12, and this would be equal to 51.3 degrees. 51.3 degrees. And if this angle is 51.3 degrees, then for this angle being 90 degree, if this angle is 90 degree, then obviously this angle on this side is 90 degree as well. Then this angle is complementary angle of theta, and this angle is complementary angle of theta as well. So this will be 90 minus theta, and this would be 90 minus theta. So both of these angles would be 90 minus 51.3. Angle at B would be equal to 90 minus 51.3 degrees, and this is going to be 38.7 degrees. 38.7 degrees. So 38.7 degrees is angle here. So this is 38.7 degrees, and here this angle is 38.7 degrees. These are the acute angles, and again this angle being complementary angle of angle at B is equal to theta, which is we have already value for, that is 51.3 degrees, because this angle is complementary angle of angle at B. So this way we have found all the acute angles of triangle ABC.